Okay, everybody, sorry about that. Stream PC decided to freeze up right at 6 o'clock. Right at 6. So we're back again. Got this relay computer that we've been doing for 7 parts now. I guess a little recap. Here we'll hop over to Firefox. This relay computer is made by a guy named Joe Allen. I got it up on the screen right now. Everything, this upper half is where the relays are. It's kind of basically a physical form of what a CPU does. You have all your logic gates and things like that. But here, let me play to see if we got some
Simon-like
clickety clack. I don't know if y'all can hear that, but pretty cool. It goes clickety clack, clickety clack. Pretty cool stuff.
See the relays halt, waiting for a change in the input. With the in wait.
So, what we've been doing, these IC sockets took forever. Last time we did all these LEDs. Got one left over here. Today, from what it looks like, the instructions, we got some transistors, which are going to go right here. Here we can flip back over to Firefox. For that, give me 1 second. Okay, so I think Firefox should be up. Yeah, so last time we did all these LEDs. Today, yeah, we got some transistors right there. Transistors right there. Ooh, we get to put the LED displays on right here. So, oh yeah, let's have fun. Let's get into it. Oh, let's switch over to our main. And yeah. Alright, so we need transistors. First one is our 2N4403. Let's hop back over instructions to double check. So yeah, transistors, install the transistors. They're all polarized, meaning there's a certain direction they have to go, so the flow of angry pixies work. The silk screen, which is the white markings on the board, should tell us the proper orientation. So yeah, we need the 2N4403. Alright, so luckily for me, I kind of haphazardly organized everything. Set that over there. That here. Resistors we don't need. What are you? Oh, one of the capacitors. We might get to that today. Maybe we get to the buttons too. Those will go right here. Alright, so we got capacitors. Capacitors. Oh no, that's transistor. This is our 24403. Awesome. Other set of transistors. More capacitors. Alright, let's get started. Okay, so that guy is awake. Go back over to Firefox, which is not working now. It is. So the 24403s looks like they're all going to go down the center right here in between these resistors. We got, yeah, that's the only ones I see. So what, we got 1, 2, 3, 4, 5, 6, 7, 8. All right, let's get to it. Sorry, I had to mess with camera settings real quick. Alright, double check, because one's 2 and that's a November 4401, but we need the 4403. I have to unsolder and resolder. Alright, so polarity wise, we'll just orient these for you. Switch over to this guy. We look right here. Our polarity should be facing this way, and luckily our transistors are shaped in the same way, so we just be alright. So it looks like my wrapped it this way so I can or you know what? Here, let me move the microscope out of here. Cool. All right, first one. Follow the silk screen. Like so. Guess let me prop this up. Okay, yeah, these are coming along. La. Okay, so I want to tack these in. Hopefully this works from top side. Clean the tip. This will help me keep you lined. I'm gonna flip the board over. Cool. All right, so those guys are tacked in. Flip the board over. Actually, you know what? Let me try something. Always a struggle trying to get the right shot. There we go. And put some solder flux on. Those who don't know, solder flux just allows solder to flow into the holes a little easier. Makes it stick where you want it to instead of where you don't want it to. This is resin core solder I am using, but sometimes it just doesn't want to do what we want. There we go. I don't know if you can see that on the HDMI on the microscope. With this guy. Yeah, see how that just flowed? Pretty cool stuff. It says it's no clean, but I'm kind of finding that I do need to go back and clean it. It just leaves kind of a gummy residue. There we go. That's everybody. That sets of transistors. Oh, no. There's that guy right there. Let me snag that. There we go. Perfect. All right. All right, so that should do it for these guys. I think I got a whole set down below. Will be these transistors. 2N4401TA, which are going to Firefox. So we did those. Those are the 3s. Now we got the 2N4401s, which is all these guys. And again, luckily the silk screen, I don't know if you can see that. Silk screen again, everything's polarized, so we gotta get it the same way. So Cool thing, I think the screens are next. One of my little little LED displays. That's going to show us like output values and things we're inputting. I have no idea how to run this thing. Cause I got I got the board back in, I think 2020. It was going to be like, you know, a project while everything else was going on during that time. But I never got around to it. But now I am. Hey, and I'm getting to share it, so I'm just doing this for fun, streaming. No guarantees I'm doing any of this right or that I really know what I'm talking about, but we're just here to learn, right? Alright. Okay, so we got 1, 2, 3. 4. 5. 6. How many do we have? According to the instructions. 1, 2, 4, 6, 8, 10. Okay. 4, 6, 8, and then yeah, 10. Alright, so we just got 2 left on this strip. Back in this bag so we know what they are. Yeah, you know, actually, we'd be able to tell too. Each component has a little marking on it. For those who don't know, you see that 4401. So. Do the same thing. I'm just gonna tack these guys on. They'll let me. Just get any pin will do. Okay. Ooh, just burnt my finger. That felt good. Yikes. Come on. Man, everything's fighting me today. That's okay. Can I get these guys to tap? Ooh, I just broached that. Come on, tap. There you go. Get these last 2. I'm just gonna do it off camera. It's not worth adjusting. Viewer might have a different opinion. Alright. Like I said, I'm just doing this for fun. Not the best solderer in the world, but we get the job done. Right there. Cool. Oh yeah, let me do the solder flux again since everybody's fighting us today. Yeah, I think that's everybody. Get a good load. Nope, missed one right there. That was an important one too. Okay. Yep, got it. Right, these handy dandy snippers. Someone pretty amazing got these for me. All right, so after these transistors, I believe we're gonna put on the little indicators, the screens. 3, 4. Alright. Oh, I thought I missed a. Oh, I missed a hold. I think that's just a through point. Cool. Alright, get a cotton swab real quick. Or a paper towel, that works too. I clean some of this resin. Or solder flux, I mean, sorry. Alright. See how everything kind of just sticks? That's why you clean it. And gross, leave that on board. Even though it says no clean. It's lies. Lies, I say. Those guys are stuck. You know, I wonder if that'd be a dub moment for me. I wonder if the smart thing to do would be to clean it first and then snip these guys so they don't get stuck in the resin. Oh well, live and learn. See, that's why we're doing this. We're learning, right? Alright, bring in the big guns. Almighty toothbrush. Some nice rubbing alcohol. Oh, there we go. Ah, there we go. Alright. Yeah, see, this stuff's nasty. Sticky. Oop. A little too much there. That's okay. It'll evaporate. Cool. Get all that nastiness away. Alright, we're cooking now. So we got the transistors in. Next, got cool components. Do these guys. So I'm pretty sure. So that's pin 1. Just little squares. Just pin 1 on these. I think it's probably like decimals down below. That would make sense, right? Right? Right. What? Alright. Let's do this. So, if anyone's ever wondering, like, where'd you get all these components? Because Radio Shack does not exist anymore. And no, it doesn't. Sad day. Yeah. Pretty double sure this is how they... Anyway, yeah, where do you get all these darn components? And cool thing is, this place called Mauser, or DigiKey. I think I got most of this from Mauser. Totally not a sponsored video, by the way. Came out of my own pocket. Like I said, I do this for fun. Yeah, you can get most of these from DigiKey, Mauser. Shipping's pretty quick too, so if you're eager to get started on your project, you don't have to wait too long, and I just probably bent that pin. Yeah, just a little bit. Not bad. Cool. Alright, so these guys I'm definitely gonna take down with some Captain tape to hold in place when I flip the board over to solder it. Alright, this is fun. I bent the pin. Cool. Alright, man, we are getting close to, man, I am so excited to finally get this thing done. Might be a 10-part series, so... You know, good things just take time, right? Alright, so we just need this. Probably did too much there. That's okay. We just need to hold this down a little bit for when we flip the board over to solder. Alright, there we go. Alright, there they are. Here, sorry, making sure we got this microscope set. Cool. Line it up. Alright, good enough. right, so we're gonna start with these, just work our way across. All right, you know what? I'm gonna probably just tack these guys in. Right here, let's do some more flex. Sorry guys, I'm trying to get this in frame for you. There we go, good enough. Yeah, let's go for it. Yeah, I'll tell you what, I should probably go like 10 times faster if I was streaming, but then again, I wouldn't be sharing it with the whole wide world. Where's the fun in that? So, anyway. Like I said, let's tin the tip, and we're just trying to tack it on so it holds its spot or its place. Oh, you're not gonna play nice, are you? Nope. There we go. That one's tacked in. That one attacking. Come on, brah. Cool. Okay, I think everybody's tacked in. All right. Got a lot of solder points on these. And clean the tip, start fresh. Alright, so we are soldering on some screens. We got some input output now on this guy. Output being this displays. Solder's on a stick. So this relay computer, in the strictest sense, it is a computer. It's not one like, you know, that you're either holding in your hand or that you're sitting at right now. Can't run Windows. I don't think it can run Linux. Probably can't. Most likely. I don't know. It's got less processing power than the Apollo computer. This is simply just a for fun thing. Kind of gives you understanding how a computer works, because it has certain logic gates built in using relays rather than transistors. For those who might not know like how a computer works, always use the kitchen analogy for how a computer works, where processor is your chef. You know, he's got all the instructions on the recipe. Your RAM memory or random access memory is the countertop or your counter space that you use to process the food. The food's the data, obviously. And then the fridge is like your hard drive or your solid state drive or disk drive, where you store things. So the chef, you know, goes in between the fridge to grab data, sets it on the counter space, processes it, and either, you know, sends it out or does something with it, restores it. And yeah, that's kind of what this is. You've got all your resistors, or your, not resistors, your relays up here. This is basically the chef. I think some of these are the memory. That's shelf space, although this doesn't have like a hard drive attached to it. I don't think it's possible to, or could be, but we'd have to probably design something to make it work. Maybe theoretically it could be, but feasible, practical, probably not. But yeah, that's kind of how it works. And so this is kind of an exploded view of like a processor. Or you have your inputs, which will be these buttons down here, and then output, that's the screens. Got some I/O up here. There's some guys out there, if you look on the YouTube, there's some guys out there that like built this huge elaborate relay computers that, I mean, they have so many relays, you gotta power it on its own circuit. It takes so many amps. It's actually not too far off from, like, you know, the old day computers that took up the whole freaking room. The tube computers. One channel I actually do like watching a lot, this guy's super knowledgeable, Dave Plummer. He used to be a Microsoft engineer. I think he did like the, you know, task manager when you have to do control, delete, all that fun stuff. But he's got a collection of old computers like the PDP-11. I think I got that right. Dave, if you ever see this, I'm sorry if I got that wrong. But channels like that, it's just cool seeing how like the old stuff operates for today. You know, it's so seamless. You don't really know how it operates, or you can't see the inner workings of it, which probably most people would care not to know or see. But hey, you know what? If you're watching this right now, you're either the nerd that cares to see, or you like learning about things. So just like me, that's what makes it fun. Cool. Alright, so that should do it for the screens. Let me clean that up again. Some rubbing alcohol. Just give those a nice little scrub down. It's not all sticky and gross. I see, like, there's some yellow residue right there. I got a Q-tip. Cool. Alright, good enough. It'll be okay. This is no clean, so should be somewhat okay. Oh no, we may have the dreaded literal bug. Like, that's where the term debug comes from, where this bug was actual insect was bridging the connections of this computer. I forget the lady's name. Can't recall off the top of my head. But so thus the term debug was born when she removed the bug from the computer. This is back in the day again of like tube PCs and stuff. But alright, cool. Alright, so that should do it for the excuse me, sorry, had to sneeze. That should do it for this LCD screens. It's not LCD in the, are these LCDs? Liquid crystal. Oh, those are transistors. LED. No, they're LED, not LCD. LED. LED. LED displays. Alright, so moving right along. We did these transistors. Let's see, that was Firefox, my bad. We did these transistors. Now we did those LED screens. What's next on the docket? Alright, so back to the instructions. Transistors, LED displays, which we did right there. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There we go. The capacitors. Little component. Alright, let's do it. So I need a 33 UF, which would be this doohickey right here. This guy. think. Yeah, 33 UF. Alright, oh, wait, where are we putting on them? I don't know. Okay. Ah, they're going all up in the up top. Cool. Alright. These are polarized too. And we gotta line up plus minus, plus minus. Yeah, I can't get these out of the strip. There we go. After I bent the whole darn thing. Good grief. Alright. So I think I'm just gonna... So that's our negative, positive. Yeah, I'm just gonna put them in. Oh, did I miss some LEDs, by the way? No, I didn't, but I think there are supposed to be some up there. Huh, maybe later. Alright, anyways. Get this tape undone on these capacitors. Up the pin off, just trying to get it out of its sleeve. Good grief. Alright, well, it is what it is. Don't gotta look pretty, just gotta work. It'd be nice if it looked pretty. One, two, three, four. See, look, it's just, it doesn't want to come off. There it goes. And it makes me pretty happy to see this whole board as populated as it is. It's been a long little project. We've just been working on it as we can. Just kind of moving along to what this is, part 7. And I don't know when I'm going to get to. There's a part in the instructions I kind of read ahead where you do like a little test power up. You don't populate all the IC, the integrated circuitry, so you don't accidentally burn it up if you didn't do something right. Man, the guy who did this glue, it's like he knew. He's like, man, someone's gonna be streaming. Let's make his life just a little bit harder, you know, just a little bit. Why his ears are burning right now. To you, sir, I say thank you for securing my capacitors onto that tape so well. Kind of a cool thing, I believe, is like, you know, the big manufacturers that make electronics, I think they get these in reels and they feed these into the machines that assemble your electronics. Not even down to the iPhone. Like, of course, the iPhone has, like, you know, super tiny. I mean, like, you need a microscope to look at it, kind of electronics, but same concept applies, I think. Oh. Cool. All right. I think that's everybody. Well, no, wait. Got una más. Yep. According to the instructions, yeah, need to populate that guy. Nearly missed him. Cool. That one didn't give us that much grief. Fire these bad boys in. Hopefully they don't fall out. What I might do is that tax strategy again. Let's see here, I did something with my solder. There it is. Did I just goof? Might just goof the board. Now we're good. Alright, never mind. Ooh, I messed up. Alright, cool. There's those set of capacitors. I think we've got, what, 4 more? Cool. Alright, moving right along. Alright, so next is our 10 microfarad. So we got Firefox. Alright, so we did our 33. I think that's microfarads. I don't know. Can't remember. Not important. As long as I know. Alright, so 10 UF. We got Uno. Ooh. Alright, he goes there. What do I do with him? Alright, 10 UF. Except, you know what? What they sent me... I don't... No, yeah, I guess they are. Alright. They just look a little different when I have the shorter end. Go over to HDMI. Look at this guy. Yeah, you see that positive. So this guy goes on the bottom of the board. I'll do main. And according to the instructions, he goes right here. So yeah, positive. Ooh, tiny little guy. That's cool. I'll go quick. There. Tin that. Don't burn yourself. Don't burn yourself. Ah! Okay, we did it. Cool. Good? You good? Good? Yeah, we good. Man, I might have to figure out a good way to clean the bottom of this board. Alright, so now next, we got our 10 microfarad. I'm gonna double check. Is that really what this was? Those are 33. And here we go. Yeah, 10 microfarads. The one yell at me in the comments. I think that says 10. Alright. Now we need our 100ers. 100 UF. Apparently. Back over to Firefox. Alright, so we did our 10. It's just one guy. Alright, 2. Oh, I got 2. Awesome. Yeah, C6, C7. Right there up top. And right by this guy down there. And why did I order this many? That's a lot. That's 33. Gosh, Double check. Did I do something wrong, or did I just fat fingered that? No, that's 100 UF. That's what the instructions say. So we're gonna do it. Alright, so we need one up top here next to where the 12 volt in goes. I'm gonna go ahead. Since it's only 2, I'm gonna go ahead and tack this guy in. Cool. Yeah, this looks kind of cool. Blah, blah, blah. That's all we need. Cool. Our stuff's getting a little tangled here. Alright, there we go. Alright, get you soldered in, and we'll get your brother soldered in. Oh no! 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 Okay, whoops. There we go. Okay, well that side's got a crap ton of solder on it. Alright, let's get the... You know what? I'm just gonna leave it. That's because it's just gonna have a lot of solder. Doesn't matter. It all works the same. As long as it's soldered good. Probably way too much. But that's okay. There's nothing around it that will hurt it. Doesn't have to be that perfect. Right, so, second one of these 100 microfarads. Cool. Alright. Cruising right along. Alright, what's next on the list? 22 picofarads? Well, you know, I did some with them. Inductors, transistors, buttons. Let me get out of order. I'm gonna forget something. Oh, here we go. Yes, it did. 22 picofarads. There's those. I think I have the 470. Yep, 470. UF. One more. Cool. Alright, let's do it. What are we doing? 22. Okay, so we got, how many do we have? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Cool thing about these, there's not a certain way they gotta go, so we can just put them in however. Hoorah. Okay, so first one is C49. I'm gonna zoom in. Yeah, C49. C41. Cool. All right. So we got 1, 2, 3, 4, 5, 6. All right. Do the tack trick again. That seems to be working pretty well. Hold one side, tack the other side. Don't hold the side you're trying to tack, you'll burn your finger. Cool. 1, 2, 3, 4. Five and 6. Alright, so we got the tack. Let's straighten things out. luckily these guys are magnetic. The smaller ones that got stuck earlier, they aren't magnetic. Means they might be aluminum or something. A little annoying, but that's okay. I'll do some cleanup real quick. See, there's one of the small ones. Got stuck again. Go away! Leave us alone. We just want to build a relay computer in peace. Oh. Yeah, a little discombobulated for this stream. That was okay. It happens sometimes. Alright. Alright, that was for the small one. Let's go back to, what was it, Firefox? Oh. Firefox? There's Firefox. That's for the 22s. For the 470s. How many do we have? 1, 2, 3, 4, 5, 6. Oh, that's the brother or sister to the other ones. Nice. Yeah, just do the same thing. Two, 3, 4, 5, 6. Yeah, I lost one. Oops. Whoops. Yeah, it worked good for the other ones. Here, let me bend these pins a little bit. Alright, so I missed that. That. Okay, this ain't working. Alright, get that one, get that one. I'll get these tacked in and I'll flip it back over, put the other ones back in. Okay, you go there. There. That should stay now. is. I can't remember this last capacitor one. Doing things a little upside down here. There we go. Cool. Alright, do the same for these. Just tack them in, get them flush, and then we'll solder everything in. 2, 3. 1, 2, 3. Cool. One, 2, 3, 4, 5, 6. All right. Let's chop off the legs to these guys. Flush with 4. 1, 2, 3, 4, 5, and 6. Okay, that's our 470s. Now we have 22 microfarad UF. Other ceramic capacitor. Yeah, I got 4 of these guys. Oh, cool. They're all in the same spot. That'll make it easy. What we want. That's face these guys out. do the same thing, tack them in, and come back and seed them and solder it. There's 1, 2. There we go. I think that's everybody. Make sure it looks good. Nope, that was not everybody. I might need my needle noses for this one. I don't know if I have them. I don't think I have them. Oh no. Yeah, here. I'll do it this way. Do it from the top. There we go. So we got our 22s in. Electrolytics, we need our 1 microfarads next, I believe. And they go, oh, we got 6. 1, 2, 3, 5, 7. They go at the ends here, looks like. We got 1, 2, 3, 4, 5, 6, 7. All right, do it. Cooking along. That's 2. Yeah, they're stuck in the real tape pretty good. Three. Let's see, I'm gonna go all on the bottom holes. Alright, there's 7. 1, 2, 3, 4, 5, 6, 7. Great. Alright. Okay, there's 470 microfarad, or no, the 1 microfarads. So now we have the 0.1. This one's got a lot. Ooh, good grief. Alright, that's a lot. Might end it on this one. After this. Let's see here. 0.1. But this should wrap up all the capacitors and stuff, so do the same thing. Well, work right from left. Actually, how many do we have? I'm counting 1, 2, 3. We gotta start with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14, 15, 16, 17, 18. 18 small guys. All right. Three, 1, 2, 3. That's what, 6, 7, 8. Got 10 more. All right, so I think that's everybody. So we got what? 1, 2, 3, 4, 5, 6, 7, 8, 9. No, wait. I can't count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. All right. Let's make sure wind the pins down here if I flip it over so they don't come out. There's 2. It is 3. There's 4. 5. 6. 7. 8. 9, halfway there. 13. 11. 12. 13. 14. 15. Let's see here. That's number 16. 17. Ah, I burnt myself again. Ouch. Mr. 17. And twice. See, get down under the microscope. Ay, ay, ay. Alright. And finally 18. Cool. Alright, so what? We got 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12. Alright, that does it. All the capacitors are in, I believe. So next time, don't know when I'm gonna stream again, but next time, get to the tactile switches. Is all that right there. I'll go through, probably off camera, clean all this up. No one likes watching the cleanup. But yeah, hit the tactile switches. I think we got some headers coming online. Some of these jumpers need to be placed. And then, man, we are close. I think maybe next time we might get a power test. Pretty sure I need to put some LEDs up here. That might be later in the instructions, but we'll go looking next time. So, all right, everything's looking good. We got a populated board. We got some screens on. It's getting close. So we'll see you next time. If you're still here, that means a lot. Thanks for watching. Yeah. So y'all have a good evening, and we'll see you next time.